We're going to go over this proof two different ways in this video. So this is about a daffodil logo. So we're going to design a logo to sell daffodils, and that's a geometric representation of the logo. Use the information given. Determine whether the measure of angle EBA, that's this angle, is equal to the measure of angle DBC, that's this angle. Well, it's always a good idea to make sure you believe it first. So what we could do is just make up some numbers for our angle measures. For example, let's pretend that angle 2 is 50 degrees. Now notice how angle 2 is a part of angle EBA, and it's also a part of angle DBC. They're telling you that angle 1 and angle 3 are congruent. So it really doesn't matter what you pick for that angle measure. Let's just pretend it's 20 degrees. That means angle 3 is 20 degrees. Now look at the measure of angle EBA. Isn't it 70? Look at the measure of angle DBC. It's also 70. So you believe that it's true. You just have to show that it works for all angle measures, not just the ones that we picked. Okay, so we have a 3-column proof set up here. I don't know that we necessarily need 3 columns. Maybe I'll just verbally talk about this middle column, but just fill in the reasons over here. Angle 1 is congruent to angle 3. How do we know? Well, it is marked in the diagram. That's what you could write here. That's given information. If you have congruent angles, how do you know that their measures are equal? That's what congruence means. That's the definition of congruence. Now, this next statement has 2 things listed, and it might be confusing to look at and to read and figure out where it came from. It's telling you the measure of angle EBA. If you look up at your picture, it's equal to the measure of angle 3 plus the measure of angle 2. It's telling you that these 2 little angles make this big angle. Little plus little equals big. Remember that? That's a postulate. Now, they're doing the same thing for the other angle. Angle 1 and angle 2 make angle DBC. Little plus little equals big. That's your segment addition postulate. And you may wonder, well, how did I know to put this here? Well, it takes some time and some experience to realize that. But what you're trying to do is you're trying to show that angle 2 is a part of both of those big angles. Okay, now, if we know all of these 3 things, then we can definitely say that this is true also. And this might take some practice as well. The measure of angle EBA equals the measure of angle 1 plus the measure of angle 2. You don't know that by looking at the picture. You know that by looking at this line. How is this line and this line related? Well, notice how we have a measure of angle 3 here, and all of a sudden it changed to the measure of angle 1. Can you take this out and put this in and still know that it's true? Well, they're equal, aren't they? You're allowed to replace one thing with another if they're equal. That's your explanation. That's called substitution. Now, if this is true, how do you know that this statement is true? Well, let's take a second. I'll use a different color here. Measure of angle 1 plus measure of angle 2 is used there and there. So we have 2 different things that equal the same thing. So what do you know about those 2 different things? They're really equal. So that's your explanation. 2 different things, that's the green things, equal the same thing. That's your transitive property. Here's the same exact problem. We're going to do it exactly the same way until we get to this step. So we have some given info. They said you had congruent angles. How do you know they're equal measures? That's the definition of congruence. How do you know two little angles make a big angle? Segment addition. Now here's where we did something differently, and this is where you can be creative. Everybody doesn't have to have the same thing. So we know these three things are true. How do we know that this is true? If you look back, this step is different than your fourth step on the last proof. If the measure of angle 1 equals the measure of angle 3, what if you added the same thing to both sides? Wouldn't that be true as well? So if you add one thing to one side, you got to add the same thing to the other side. That's your addition property of equality. So we now know that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 2. Now look around for a second. Here's the measure of angle 1 plus the measure of angle 2. Here's the measure of angle 3 plus the measure of angle 2. I know these are two different things, but aren't they the same as each other? So if these two different things are equal to two things that are the same, what do you know about these two things? They're equal to each other also. So you can use that transitive property right there to finish. Or here's how they did this in this proof. Measure of angle 1 plus measure of angle 2 equals the measure of angle DBC. So you take this out and you put in what it equals. Measure of angle 3 plus measure of angle 2 equals measure of angle EBA. So you take this out and put that in. You're replacing things that are equal. That's substitution. And then if these two angles are equal, they're equal if you write them the other way. So you can flip the equation. That's your symmetric property. I wanted to make sure we took some time to go over this and you had some time to watch this, because we're going to reference this daffodil proof a lot. And you're going to notice that the steps in proving this look the same regardless of what type of problem it is. We're going to use the same type of steps.